Suppose you were the owner of a television station or a satellite, which could broadcast just one television program. And somebody came to you and said, with the same amount of power, you can broadcast not one, but 10 programs. What would that be worth to you? Obviously, it would multiply the value of your investment 10 times overnight. Well, that's the sort of thing that fractal geometry makes possible. Atlanta, Georgia, headquarters of Michael Barnsley's Iterated Systems. In 1991, Barnsley received a $2.5 million government grant to develop fractal image compression systems. Corporations such as Microsoft, Mitsubishi, Multicom, and Virgin now use Barnsley's image and data compression software.
One of the most exciting moments occurred when I discovered the collage theorem. We'd been trying to work out how you could control a certain class of dynamical systems to make pictures of leaves. Then, struggling with the question, it just dawned on me that it was very simple. You needed to form a collage, a covering of the object with copies of itself, smaller, shrunken copies, so that the whole object was tiled with copies of itself. It's a self-reference statement. It's as though you took instead you might take a triangle and cover it with little triangles. You might take a square and cover it with little squares. Well, the theorem said if you took a fern and covered it with little ferns, then you would have created a dynamical system or a formula for a fern. But if you tried to actually create a picture using the collage theorem, it took hundreds of hours of graduate student time working on the problem. And the holy grail at this point for us became the question of, could we find a way to tell a computer, just look at a picture, a digital picture, and automatically go ahead and find the fractal formula for it. The discovery of how to automatically calculate the collage for an arbitrary picture came to me in a dream. From the early days of doing mathematics, I used to have a recurrent nightmare, which was something to do with studying matrices. And they kind of remind one of perhaps an old-fashioned telephone switchboard. Well, in the dream what happened was there was thousands of holes and lots of wires connecting everywhere to everywhere. And it was always a sort of tense muddle between the switchboard with all the wires going everywhere, always in a horrible tangle, and somehow it represented a matrix. I'd had this nightmare many, many times over 20 years. Night of the anniversary of my father's death, 2 years after, suddenly I saw in the dream how you could straighten out the switchboard, how all the wires would become untangled and nicely connected, and how you would join all the wires from big blocks to little blocks in the grid. And I woke up in the morning, I knew I'd discovered it, that this was it. This was the total secret to fractal image compression. How to automatically look at a digital picture, these ones made of the low resolution input, like your eye receives, and how to turn it into A, a formula, and B, an entity of infinite resolution. So the goal is now to be able to capture this fire of Prometheus, if you like, this fractal wonder, put it in a box, and being able to make this available to everyone.
Using Michael Barnsley's system, we can now compress images so they require drastically fewer bits to store them. Now, whether you compress or expand an image depends on the same fractal principles, and Barnsley's theories have now become a commercial reality. Let's take a look at one of his programs. If we take a tiny piece of this image, which has been stored in digital form in the normal way, and blow it up, it becomes very pixelated, and they're huge pixels. Now, if we take this very coarse image and pass it through Barnsley's fractal analyzer, we can actually reconstruct the details of the original image. If we then put the two images side by side, the difference is startling. So, where has all this detail come from? Well, this fractal image is a prediction based on the digital data sampled at the original low resolution. And you can, of course, magnify this image just as much as you wish, because, Like the M set, it has infinite resolution.
What you see are fractal textures, fractal creations that mimic the missing data. They are, if you like, interpolations or predictions, but they're done using fractal geometry. What happens is the original data is modeled by a fractal formula, and then we're looking at that fractal at greater and greater detail.
We're all used to seeing, every night on TV, the satellite view of the Earth with clouds moving over continents, showing the formation of storms and so forth. Now, those weather satellites have been operating for decades. What is not so well known is that there are also satellites up there, so-called spy satellites or reconnaissance satellites, which produce images of the Earth, or at least points of particular interest to the military, with thousands of times the definition of the weather satellites. But this means they have to transmit tremendous amounts of data to the ground, far more information than the weather satellites. So therefore, data compression, the ability to squeeze images and send them and then expand them again on the ground, is of enormous importance to the military. And we can thank those satellites for the fact that World War III is not yet broken out, and hopefully never will break out. Fractal geometry also has surprising applications in medicine. This is the blood circulatory system of the human body, and yet you'll recognize it. It is a kind of fractal. Now we can understand what is really happening when our blood circulates. Here is the most important fractal of all in the human body, a small portion of the incredibly complex wiring circuit of the brain. We may never understand how our brains work, but if we do, I suspect they'll depend on some application of fractal geometry. Why I think there may be some connection between the Mandelbrot set and the wiring of the brain is because when I close my eyes and press my fingers against my eyelids, I see these patterns. I'm sure you're all familiar with them. You also see them when anybody gives you a bang on the head. Well, sometimes these patterns echo some of the shapes of the Mandelbrot set. Also, I'm told, I have never tried the experiment myself, that when certain illegal chemicals are ingested, you experience visual hallucinations strikingly similar to some of the patterns of the Mandelbrot set. Why do these strange patterns have such an appeal? Well, obviously they trigger some kind of resonance in the mind. And incidentally, there's an odd coincidence here. The name Mandelbrot and the word mandala for a religious symbol. I'm sure it's a pure coincidence, but indeed the Mandelbrot set does seem to contain an enormous number of mandalas or symbols. The paisley pattern is one, and I'm sure there are many others. And in ecclesiastical design, such as stained glass windows, particularly in Islamic art, you find many echoes of the Mandelbrot set centuries before it was discovered.